New book, new unit. So we're on Unit 6, page 521 of your book, Organizing Data. So here is a table. Each row shows two measurements of a triangle. What do you notice? What do you wonder? So this can be anything. I notice blank. I wonder blank. It's your choice. Something could be, I noticed length of short side isn't in order from smallest to biggest. This would be considered our X and our Y of our table. X values aren't in least to greatest. I mean, it could be something else. It's your choice. I wonder. It looks like one word. I'm sorry. I wonder why it gives us the short side, not the long side. List the short side. Really, those can be anything. What you notice, what you wonder. Remember, that is a your choice. What do you notice or wonder? Next page. We have the same table as the warm-up, but how can you organize the measurements from the first table so that the patterns are easier, to see? So this is your choice of how it works. For me, my brain just works smallest to largest. So that's the order I'm going to go in. Our smallest measure on my short side, my X value, is 25 hundredths, or a quarter. So that's what I'm going to put first. And its corresponding perimeter is 1. So I'm going to cross it off. Next smallest is a half. Its perimeter is 2. Next we have 1. And its perimeter is 2.5. Then we have 1 1/4. Its perimeter was 3.5. Then we have 1.5. And its perimeter was 5. Next would be 2 and 7.5. And then 3 and 9.5. 3.5 and 12.5. 4, 14, and our last one would be 6.5 and 22. So we did it from least to greatest, and this ended up being least to greatest as well. For each of the following, I'm on number 2 down here. Estimate the perimeter of an isosceles right triangle whose short sides have that length. Explain your reasoning for each triangle. So if the length of the short side is 3/4 of a centimeter, what could make sense for the perimeter to be? Well, we are given half and we are given 1. So right in between those two, so probably right in the middle of these two, would be a good estimate. So 2 1/4. My first thought when I saw 3/4, I was like, oh, I can add 1/4 plus a half, which is 3/4. But that would give me 3, which is more than the perimeter of this triangle with the length of 1. So then I thought it must be in between there. So if we have short side is 5 centimeters. So we are given 14 and we're given 6.5. So probably somewhere in between there, but closer to the 4 than the 6.5. So if we are given 4 and it's 14, then we have 5, 6, 6.5 is 22. Somewhere in between there, but closer to here. This might be 20. I'm really not sure. So then we have 6 between here. So maybe 17. Remember, these are estimates on what you think it could be. So 17 would make sense. We could do 4 and then plus your 1. So plus 2.5, which gives us 16.5, which is close to that 17. So somewhere in there. 10 centimeters. Well, we could double our 5 because remember we're estimating. So it's close to it. So 5 centimeters was 17. 10 centimeters could be close to 34. Remember, might not be exact, but close to it. I'm sorry, centimeters. My reasoning is all be based on what we have on the table, and then I kind of drew like a double number line to kind of get estimates of what it could be. The next thing is a activity where we have cards along with this table. So we're going to not be able to do card sort exactly, but I can show what the cards look like and we can match them based on that. So my first card is 30 days in August. So we have temperature, daily high, and then energy consumed. So we had to figure out which table has values that would represent this. So this first one, we're in the thousands, 10,000s. This isn't. These are just the tens. We have 100. Otherwise, we have 10s, 20s, 30s, 40s, all the way up to 100. So this one can't work. Then we have this next table, which goes from 72 to 102. So this, we have 77 is the lowest I think I see. 77, 76. Which, okay. So 72 could work. This is a 1,000 and then 9/10. So my guess is this is 30 days in August. Makes the most sense. Because all of these dots are kind of in between the 25 and 45-ish. And all of these values are in the high 20s, 30s. So at the top, you would write 30 days in August. And then on your tables, remember that first one is always your X value because your tables are in XY order. So we have daily high, and it's in Fahrenheit. And then we have energy. And it is measured in kilowatt hours. So I'm going to put KW for kilowatt. The next table we have is diamonds. 20 diamonds. So we have singles. We have 1 and 5/10, 1 and 500ths, 1 and 2/10, 1 and 3200ths. So our biggest number is 2. Our smallest number is 1. The only graph that has X values with small numbers is this one right here. Because we have 9/10, which none of them are on 9/10. They're all a little bit past. And none of them are on 2 and 1/10 yet. And our biggest number is 2 and 400ths. So this would be 20 diamonds. And we have our weight. And it's in carats. I don't know if there's a abbreviation for that. And then we have price. And it's in dollars. Next card we have is 20 new cars. So we have mass. Sorry, I got distracted by I don't even know what. We have mass, which is its weight in kilograms, and we have its fuel efficiency. So we have 2 graphs left. We have this one, which is in our 30,000 and higher, and then up to 6,000. My Y value on this one doesn't have thousands. It has numbers in the tens, 20s, 30s, and that's as it goes. So that means this one makes the most sense because our weight is all within these values, and our fuel is all in these values. So this is 20 new cars. We have mass, and this is in kilograms. And then we have fuel efficiency. I'm going to write miles per gallon because I don't have room to write fuel efficiency. And then our last one must go here. We have 20 used cars. And our X would be its price in dollars. And then this one isn't fuel efficiency, it's how many total miles does it have. So it's mileage. And it's in miles. That brings us to our lesson summary. So far, we have been dealing with scatter plots. A scatter plot is a way to demonstrate your data. You're able to see patterns within it, and you're able to put all the points that you're given. So this is an unorganized table, which is hard to see what goes on, and then to organize your table so you can see if there's a pattern between going from smallest to greatest and what that pattern might be. And then brings us to problem set. So we have this set of data. Goes from 1939 to 1955. It is not organized. So we need to make a new table that orders the date by year. So do your best. We have years. We have number of cases. I probably didn't do enough lines on here. This one's kind of big, so I can cut that in half. Circle the years in your table that had fewer than 1,000 cases. So you're going to go through your table and you're going to circle both the year and the number of cases it had. When I look on this set, I have 1, 2, 3, 4, 5, 6, 7. You should have 7 that are circled. 7 years and cases. Based on this data, would you expect 1956 to have closer to 50,000 or closer to 100,000 cases? So you're going to have to look at, probably 1954, 1955, and see what do those have. And then is your number going to be closer to 50 or 100,000? Number 2, volleyball stats. A block is recorded when players deflect the ball hit from opposing team. Additionally, scorekeepers often keep track of average number of blocks a player records in a game. So we have blocks per game. On your table, it's an X, Y order. Label the axis of the scatter plot with the necessary information. So our X is number of blocks. Your Y is blocks per game. Number 3. A cylinder has a radius of 4 centimeters and a height of 5 centimeters. So this is a review from Unit 5. Cylinder. Radius of 4, height of 5. What is the volume? So we have pi r squared times 5. What would that equal? Next, what is the volume of a cylinder when its radius is tripled? So my radius is no longer 4. My height stayed. 4 tripled, so 4 times 3 would be 12. So my new formula would be pi 12 squared times 5. What is the volume of the cylinder when the radius is halved? I should have drawn my original one bigger. That's okay. So half of 4 would be 2. My height is still 5 though. So we would have pi 2 squared times 5. Obviously, you need to put those in your calculator and see what they equal. And that is the video for Unit 6, Lesson 1.